Welcome to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College. The subject that I am covering in my lecture series is Embedded System. Subject code is KOE 062. The topics that I am covering today are in-circuit emulator, target hardware debugging. So, let us go into details. So, as we all know that a typical assembly language development environment will include these things, like there should be assembler, linker, instruction set simulator, debugger, development boards, in-circuit emulator, software libraries. So, let us have a brief overview of all these. What is assembler? Assembler is the software module that will convert your assembly language program into the machine language, because machine language is understood by the machine, by the system, and the programs that we write are in the form of mnemonics, are the English like words. So, that is the assembly language program. So, the software program that will convert our assembly language instructions into the machine language, that is in the form of 0 and 1, that is in the form of bits, bit series. So, that is the assembler. Next is the linker. What is linker? So, whenever we design any embedded system, as we have already studied in the previous slides about the build process. So, we came to know there that there is a linker device that will link all the different object files, multiple object files, and will give a single object file, that is a single executable file as an output. So, the device that will in fact, this is not the device, this is a software that will link all the object files, and in return it will give a single executable file, that is a final file, that is the linker. What is instruction set simulator? So, this is the simulation tool that will simulate all the instructions according to the processor that we are using. So, different processors are having the different instruction sets. So, according to the processor that we are using, this software, that is simulator is a software. So, this software will particularly simulate all the instructions, will debug all the instructions, will judge all the instructions related to that processor, and it will judge the nature of the instructions related to that particular processor. So, this is the work of instruction set simulator. Now, the next is debugger. What is debugger? This is again a software which will find the bugs, which will debug the instructions, that will debug our programs, our softwares that is related to our processor, that is related to our hardware. So, the role of the debugger is to find out the bugs, is to find out the bugs and remove the bugs from our program, from our software. Now, the development boards. What are these development boards? As you have already seen, you must be knowing that whenever we design any embedded system, we select certain processor, right. So, whenever we purchase any processor, so the processor is a single chip, but in actual it is present on a board, and in that board, on that board we can see the various circuits, various peripheral devices, various other ICs apart from the processor IC that is present on that board, and that is not the extra part, that is the essential part, which is the integral part of the processor environment, which is needed for the embedded application. So, that is known as the development board, a board on which the main processor chip along with the different peripheral ICs, or we can say the different control circuitries, all those circuitries and the peripheral ICs and all the required circuits are available on that particular board along with the processor IC, that is the development board. Now, what is in-circuit emulator? That we will go into details, but as a short piece I can tell you that in-circuit emulator is that is emulator means something that emulates the other, like it mimics the role of some other processor. So, in circuit emulator is basically a device that will mimics the role of the main processor to debug it, to find the bugs, to test the conditions, to test the results and see if the main application is working according to what we want out of it, according to the demand. Okay. So, that is the role of in circuit emulator. Software libraries are the series of files, series of softwares which are required for the processing of the application. So, that is the combination of all the files which are required for running the software related to the embedded system that we have designed. So, those comprise those make the software libraries. So, let us see the relationships between all those components which we have seen in the previous slide. So, here we can see this is the high level language code. Suppose this is the high level language code. This is the object code libraries, assembly code. So, there are two ways of giving the code as an input to our program, to our device. So, there are two types of codes, either we write it in the high level language like C, C++, Fortran, these are the high level languages, or we can write it in the assembly code. Assembly code means that is the assembly language, that is the English like words we know. So, 8051 is having a different syntax, some other microcontroller will be having some other syntax. So, all the processors and the microcontrollers, these are having the different syntax and but these are all the assembly languages. So, the R code may be in the form of assembly language or may be in the form of high level language. If we are writing the code in the high level language, then where it will go? How will it be compiled? Using the compiler. Okay. So, what will the compiler do? Compiler will convert the high level language into the machine language, that is ultimately it will give us the object file. But if we write the code in the assembly language, then what is the role? Then assembler will convert the assembly code, that is the code written in the assembly language, into the object code, that is the bits in the form of the machine language. So, either we write the high level language code or the assembly language code, both will be converted into the object code, either using the compiler in case of high level language or by using the assembler in case of assembly language. So, finally, we are here with the object code. Now, object code will give to the will go to the linker. Okay, so, the different object codes along with the object code libraries, they will go as an input to the linker device. Linker will give the binary executable file at the end. Yes. So, we are here with the binary executable file. This will go into simulator. Simulator will know the nature of the will judge the behavior, will test the behavior of all the codes and will see if the code is working according to what we have desired. So, this is the role of the simulator. Now, the host computer debugger, this is the host computer where the debugging process is done. So, simulator and debugger are here and this is the target DSP system and this is in circuit emulator. So, the in circuit emulator is the device which is present in between our target device and the host computer. So, this is connected between the target device and the host computer and it will see the actual if our application is actually doing the same way that we have desired. So, that it will test the actual process, actual nature of the application, if it is working properly or not. So, what is the need for the IC? IC means in circuit emulator. So, embedded systems lack a display, keyboard and the mouse with which to manipulate the microcontroller that we are trying to program. Okay. So, we all know that whenever we design an application, suppose there is the microwave oven or there is a washing machine, either do we have any keyboard or the mouse along with that device? No. So, how we will test the nature of the software that we have designed for that particular application. So, for that we need a keyboard, we need a mouse to make the changes and all. So, now how we will do the manipulation? So, a host computer is used for that purpose. It is used for this function and is typically communicates over a serial cable or more recently Wi-Fi. So, either we can connect our system with the host computer using a cable, or we can do the same using the Wi-Fi also. Recently, as the technology is advancing, so Wi-Fi is a very good option for that. Once we create, edit and compile the code. So, all these the essential processes have been completed for our code, that is a create, edit and compile. For our embedded systems on the host computer, then we will have executable object code that needs to be uploaded. So, that is the object code is the one which needs to be uploaded to the microcontroller in our embedded system. So, now we can see the code in the action. So, once the code has been checked for the bugs, it has been created, it has been edited, it has been compiled, it has been checked for the bugs, it has been edited again, then finally the object file which is obtained at the end, that is uploaded into the embedded system. Now, we can test either the whether the code that we have designed is working properly according to the application or not. Now, it can be debugged also again by making the changes to the code on the host. Now, we can again make the changes by using the host computer, then we can again upload it and test on the target device. So, in this way the host computer is used to again and again debug it, to check the software, to debug it, to make the changes, then again uploading it. So, in this way we need a host computer for that purpose. Now, so what if we want to alter the contents of a register, memory or the state of your input output to see what happens. Now, okay, the code is done, we have made the changes to the code, we have again uploaded it. Now, the code is running on the application. Now, what if we want to make the changes to the memory, if we want to make the changes to the register, if we want to make the changes and see the effect, what actually it is in the application, when it is working in the application, we want to see that, not on the host computer, but we want to see the effect of change we have made on the application directly. Then how we will do that? So, for that purpose there is ICE, that is in circuit emulator. So, what is this? This is a debugging tool that allows you to access a target microcontroller unit for in-depth debugging, that is debugging it according to the changes, according to the nature of working of the code when it is present in the application. So, a genuine ICE requires us to remove the microcontroller and to insert the ICE in its place. So, what it is actually done, this is the mimicry basically, that is why it is known as, it is not known as the simulation, but the emulation, because it emulates the actual microcontroller. It is the copy of the microcontroller, it is not the actual microcontroller, but it is the copy, it is the emulation of the microcontroller. So, basically what we do, we remove the main microcontroller and we replace it with our ICE device. So, the ICE device is placed at that position and most commonly using an adapter. So, there is an adapter for that, and using that adapter the main microcontroller is replaced by the ICE and we can test the actual working of the code on the target hardware. So, in this way it is helpful in judging the actual working of the code in our application. So, it consists of a hardware board with occupying software for host computer. It is physically connected between the host computer and target MCU, second thing. So, the debugger on the host establishes a connection to the MCU via the ICE. Okay. So, the debugger basically what it does, it makes the connection between the debugger and the host. So, it allows a developer to see data and signals that are internal to the MCU. Yes. So, this is what we want to see. this is the thing that we wanted to judge. We wanted to see what if the changes are made to the to the memory, what will happen if the changes are made to the register values. So, this is what we wanted to see, and to step through the source code or set the breakpoints, the immediate ramifications of executed software are observed. What are the ramifications? These are the unexpected behavior. Suppose the code is not working according to what we have desired, what we have planned. So, those are known as the ramifications. And what are the breakpoints? At certain points in the code, we set those places where the code is used to see the for the debugging purpose. There are certain places at the code in the code, those places are fixed where we want to see how the code is working. If there is any bug or not, if the code is working properly or not, those are set as the breakpoints. This type of debugging is also referred to as the source level or the runtime debugging, except the ICE is as close to the real scenario as possible. So, this is not the real scenario, but it is as close as to the real scenario that is why it is not a simulation, but a substitution of the target MCU with an emulation or accurate mirror. Emulation means it is a mirror image, that is it is not the product actually, but it is the mirror of the product, that is it is a copy of the product. So, in this way the ICE works. So, we can have a look at this diagram also, that we can see that this is the target hardware, and this is the host computer, and there are the transmission and the reception lines through, and using these lines the in circuit emulator is connected to the host computer. This is the in circuit emulator, that is the target system emulating circuit, and this is the communication port through which it can be connected to any peripheral device, and this is the main target hardware, and through the cable this emulator circuit is connected to the main target hardware. From the target hardware, this is the socket for the microcontroller, for connecting the microcontroller microprocessor. So, while using the IC, what we actually do, that if we remove the microcontroller from its actual socket and we replace it with the ICE, but here instead of plug-in process we are doing the same using a cable. So, this is the actual diagram. We can see here that this is the target device and this is the adapter, and we are connecting using the adapter, we are connecting the emulator circuit to the target hardware. So, this is the actual image of the process. Now, after ICE, there is another debugging technique, that is the target hardware debugging. So, we have tested all the codes, we have seen the nature of the codes, we have seen that the code is working according to what we have desired, but still the final results are not according to the plan. So, why it happens and how it can be removed. So, what it is saying is that even though the firmware is bug free, okay, firmware is all the software related to the hardware. So, that is the firmware, but the embedded product need not function as per expected behavior. Why it is happening? This is because of dry soldering, missing connections, unnoticed errors in PCB, etc. So, what are these things? Dry soldering. So, you must have observed that while doing the soldering, there is certain dull structure which has been formed just after the soldering, and that dull structure is known as the dry soldering. It is not a proper soldering. The effect of the dry soldering is basically the contact may remain open, or it may not be the proper contact. So, the dry soldering leads to unwanted results, it leads to the open circuits. Missing connections, again there may be, while doing the continuous soldering, some connections may be missing. So, that will lead to unwanted results. unnoticed errors in the PCB. There may be, since PCB is a very small device, so there may be certain errors, there may be certain points where we are missing the bugs, that we are missing the point that where there is a connection issue or some device may not be connected properly. So, these may result in the unwanted unexpected errors. Debugging the target board is the only way. So, what is the remedy for that? That debugging the target board is the only way to sort out these issues. So, how can we debug the board? So, the whole board has to be debugged. So, there are various devices, and most of those, some of those devices you must have seen in your laboratories also, and those commonly available devices are used to debug the target hardware. So, basically hardware debugging is what? It is the monitoring various signals of the target board. At various checkpoints, the signals are checked on the target board, or then checking the connections between the components, circuit continuity checking whether the circuit is continuous or not. There must not be the short circuits or the open circuits. So, these are the hardware debugging tools. Let us have a quick review of all these tools, because as you have already seen in your labs, all these things are available in your labs. So, first is the magnifying glass, that is a simple lens. Next is the multimeter. Multimeter is a thing that is used to judge to test various signals. Digital CRO, that is very common in all the labs, basically the electronics, basic electronics labs, and in this the digital CRO is used to check the glitches, check the errors or the noises present in the various signals on the screen. Logic analyzer is used to test the digital signals and to test if the digital signals are obtained properly at different points. Function generator is another thing, it is used to generate various types of signals needed at different points. It may be sawtooth wave, it may be the square wave or the sine wave, etc. So, this is the magnifying glass, you must all be well aware of this. So, in the complex systems there may be many CFL tubes are also attached to this magnifying glass. So, the station may incorporate multiple lenses also. Main lens acts as the inspection tool, and the small lenses are used for magnifying the small areas present in and around the device to be checked. So, this is one of the tool. Multimeter is another, it is used for checking the circuit continuity, signal values, polarity, measuring supply voltage, etc. This is very commonly available in all the laboratories. Another is the digital CRO. So, this is again very useful in analyzing the interference, noise in the power line and other signal lines. So, here the signals in the blue screen, the signals can be traced and can be seen for any noises, any glitches, and it is suitable for the high frequency support and best suited for target board debugging. Another one is logic analyzer, it is used for capturing the digital data from the digital circuits, and those digital data is judged at the different points and to see if the signals are obtained properly. So, they give the exact reflection of what happens when the firmware is running. Function generator, it is another input signal simulator tool, and it is used to produce various periodic waveforms like sine, square, sawtooth waves, etc. It is in the debugging environment, the function generator serves the purpose of generating and supplying the required signals. So, this is the main purpose of this device. So, that is all for today. We have covered the debugging tools for the target hardware debugging and the that is the in circuit emulator. So, that is all. Thank you.